Hello and welcome to Maths by SAS. This is my third lesson of D3, chapter number 6, exercise 6a, that is about the gradient of straight line. If you find any difficulty about understanding that what is the gradient, what is the symbol, what's the formula, and what is the condition for 3 points to be collinear, you have to watch the previous lesson, for which I'll give the link in the description box, because the lessons of mathematics requires the continuous practice and integration of the lesson with other lessons. Okay, let's move to question number 5, and let me read the question from the book, as the questions are long, so I've written the question in short form. Question 5 says that the gradient of the line joining the points 9a and 2a and 1 is 2 by a, where a should not be equal to 0. Find the possible values of a. Okay, it's really important to underline and understand important terms of the question. Given points are 9 and a and 2a and 1, and 2 by a is the gradient of this line, and the requirement of question is that we have to find the possible values of a. It's really important to understand that here the question is not asking us to find the value of a. Question says values of a. So it means that when we'll be solving this question, we will be getting more than one value. And if at the end you're not getting more than one value, you have to stop and recheck your calculation, because the question requires more than one values. Okay, so let's begin the solution. Question is not giving any name to the point, so it's better to give some name, because this is a symbol of because. A is 9 and a, and b, there is no harm to mark the vertices 2a and 1, and the given gradient is m is 2 by a. Now what will tell us that what are we going to do with this question in order to get value of a? As the gradient is given, answer of the gradient is given, so with the help of the points we're going to find the gradient, and we have to equate these two gradients. Okay, so what will happen, that gradient of AB will be equal to this 2 by a. Now let me insert the values carefully in the formula, and y2 minus y1, 1 minus a upon 2a minus 9 will give me, or we can equate it to 2 by a. Okay, now I have to write a carefully. 1 minus a and 2a minus 9. Okay, now we have to go for cross multiplication. This is a into 1 minus a equals to 2 into 2a and minus 9. Now I have to simplify both sides of the equation, and equation will take the form a minus a square equals to 4a and minus 18. Okay, I'm simply multiplying and applying distributive property, and we are multiplying this 2 with every term inside the bracket. Now bring all terms on the same side and make it in the form of the equation minus a square plus a. When I'm shifting this 4a to other side, minus 4a and plus 18 equals to 0. Now minus a square and 4a and a, I have to solve them. 4 is having the minus sign, minus 3a plus 18 equals to 0. Now what I have to do, I have to make the coefficient of the square term positive, so I can pull out this minus sign, and equation will take the form a square plus 3a minus 18 equals to 0. Shift this minus sign to other side, and equation will take the form a square plus 3a minus 18 equals to 0. Now recall that what type of equation we are getting here. The maximum power of the variable is 2, and so this will be the quadratic equation. Now how to solve this equation? There are two methods available. One is the midterm breakage method and the other is completing square method, or you can apply the quadratic formula. But let me see whether we can solve this equation by hit and trial methods. So according to the hit and trial method, I have to make the factors of 18 to 9s and 3 3s are. Now I have to set the factors in this way that when we are adding or subtracting, we can get 3, and when I'm multiplying, we can get minus 18. So if I'm taking 6 and 3, 6 and 3, 6 with positive sign and 3 with negative sign, I can solve my problem easily. If you find any difficulty about the midterm breakage, you have to watch my previous lesson of D2 chapter number 3 exercise 3b, because the method of midterm breakage is really important and it is applied at many places in the next classes. So what we have to do, we have to write on the breakup of middle term a square plus 6a and minus 3a minus 18 equals to 0. Now make the groups of like terms, okay, and from each group extract or pull out some common factor. If I'm looking and checking the first group, I can pull out a, and inside the bracket I will be left with a plus 6, and from the second group I can extract 3 out, minus 3 out, and inside the bracket I will be left with a plus 6 equals to 0. Now we can see that this a plus 6 is the common group. A plus 6 is the common group. I have to extract it, pull it out, and the equation will take the form a plus 6 into a minus 3 equals to 0. And then recall what we were doing to get value of the variable. We have to apply either our condition, either a plus 6 equals to 0 or a minus 3 equals to 0. In order to get value of variable, I have to shift the constant to other side and I have to change the signs as well. So a equals to minus 6 or a equals to 3. So these are the two values of a. So the possible values of a are a equals to minus 6 or 3. I hope you are clear about this question. For this question, you should have the command on two concepts. One is the concept of the gradient and the second is the midterm breakage. Okay, let's move to the next question and let me read the question carefully. From the book, question 8 says, the line joining the points A, 2 and T, B, 7, 2t square plus 7 has the gradient of 2. Find the possible values of t. Okay, again, if we compare question 8 with, in both the questions we are given with 2 points and the answer of the gradient, and we have to find the possible values of t. So try to solve the similar questions at the same time for better understanding of the concept. Now what we have to do, because the given points are A, 2 and T, and B, 7 and 2t square plus 7, and the gradient which is given in the question is 2. Okay, so I hope we are clear that what we will be doing here. Again, we have to find the gradient with the help of these 2 points. Okay, so y2 minus y1, this is y2, and this will give me 2t square plus 7 minus t. This is y2 minus y1 upon x2 minus x1, 7 minus 2, and this will be equal to 2. Now what I will be doing, I will be rearranging my numerator, 2t square minus t plus 7, and I have to solve the denominator as well, upon 5 equals to 2. Now what we have to do is that we have to shift this 5 to other side, 2t square minus t plus 7 equals to 10. as 2t square. If we look at the maximum power of the variable, it's 2, so it's a quadratic equation. So we know that in quadratic equation, all terms must be on the left hand side and right hand side must be equal to 0. So bring 10 to other side. So it will take the form 2t square minus t plus 7 minus 10 equals to 0. 2t square minus t minus 3 equals to 0. Now this is the standard quadratic equation, and now I have to think about the technique by which I can solve this. If I'm trying the midterm breakage method, I have to multiply 2 with 3 and this will give me 6 with minus sign. Now I have to think about the factors of 6 that can give me minus 1 and minus 6 at the same time. So if I'm choosing the numbers 3 plus 2, minus 3 plus 2 can give me minus 1, and when I'm multiplying them I can get minus 6. So please you can understand that midterm breakage is really important. Okay, now 2t square minus 3t plus 2t minus 3 equals to 0. Now make the groups of like terms. Okay, if D2's chapter 3 is clear, then next many concepts will be clear to you. From each group you have to extract, pull out some common number or letter. Like from first group I can extract t out, and inside the bracket I will left with 2t minus 3. Coming to the second group, I cannot find any number common here, but we know that 1 is the factor of every number, so I will be pulling out 1 here, and inside the bracket I will left with 2t minus 3 equals to 0. Now see it carefully, that 2t minus 3 is the common group. I have to extract it, pull it out. So extract 2t minus 3 out. 2t minus 3 into t plus 1 equals to 0, and now apply either or condition, that either 2t minus 3 equals to 0, 2t minus 3 equals to 0, or t plus 1 equals to 0. In order to get value of the variable, I have to shift this constant to other side. 2t equals to 3, and t will give me 3 by 2, as the numerator is larger than the denominator, so you have to give your answer in mixed number, 1 whole 1 by 2. Okay, or what we can do is that from the second equation, when I'm shifting t to other side, t will be equal to minus 1. So the two values of t are t equals to minus 1 or 1 whole 1 by 2. I hope you are clear about this lesson. And let me move to the next question, and let me read the question from the book. Okay, question 9 says, the coordinates of the vertices of the square A, B, C, D are A0 with 6, B2 with 1, C7 with 3, and D5 with 8. Yes, find the gradient of all four sides of A, B, C, D. Okay, and what do you observe about the gradients of the opposite sides of the square? Okay, let me move to the solution of the question. And the first requirement of the question is that we have to find the gradient of all four sides. It means if you find any difficulty in understanding the question in this way, you can make a rough sketch like this. Now what we have to do, we have to find the gradient of all four sides. So first let's move in the order. The first one is gradient of AB, MAB. Okay, and A has the coordinates 0 with 6, 0 with 6, and B has the coordinates 2 with 1, 2 with 1. Okay, let me underline this, highlight these 2 points. Okay, now I have to apply the formula that gradient equals to, okay, y2 minus y1 upon x2 minus x1. That will give me 1 minus 6, 1 minus 6 upon 2 minus 0, and this will give me 1 minus 6 is minus 5 upon 2. Okay, so let me make it m1. So m1 equals to minus 5 by 2. Okay, and let me encircle this answer m1, that is the gradient of AB. Now what we have to do, gradient of BC. Okay, try to go in the order so that you should not skip any part of the question. BC, gradient of BC, and B has the coordinates 2 and 1, and C has the coordinates 7 and 3, 7 and 3. So M2 will be equal to 3 minus 1, 3 minus 1 upon 7 minus 2, 3 minus 1, 7 minus 2, 2 upon 5. Okay, so M2, the gradient of BC equals to 2 by 5. Okay, and let me block this answer quickly. Okay, and then we have to find the gradient of CD. Gradient of, third one is gradient of CD, and the C has the vertices 7 and 3, and D has the vertices 5 and 8. Now M3 will be equal to 8 minus 3, 8 minus 3 upon 5 minus 7, 5 minus 7. This will give me 5 upon minus 2, or I can write it minus 5 by 2. So M3, the gradient of DC is minus 5 by 2. M3 equals to minus 5 by 2. Okay, I'm making it and writing it in red because in this way we can differentiate the gradients of opposite sides and compare them easily. Okay, the next part, the fourth part, is that gradient of DA or AD, AB, BC, CD, and DA equals to, and D has the coordinates 5 and 8, and A has the coordinates 0 and 6, and the gradient will be equal to 6 minus 8, 6 minus 8 upon 0 minus 5, which is equal to minus 2 by minus 5. Now this minus sign can go, the minus sign can go with this minus sign, and this is my M4. M4 will be equal to 2 by 5, 2 by 5. M4 equals to 2 by 5. This was the first requirement of the question, that find the gradient of all four sides. And after finding the gradient of all four sides, the second requirement of the question is, what do you observe about the gradients of the opposite side of the square? What do you observe about the gradients of the opposite sides of the square? Now if we look at AB has the opposite side CD. AB has the opposite side CD or DC, and if we observe the gradients of, sorry, this is 2, let me correct it, this is 2. Okay, so always recheck your work before submitting. Gradient of AB equals to gradient of CD. And now if you look at BC and AD, they are opposite sides, and if we look at their gradients, gradient of BC, okay, is 2 by 5, and gradient of CDA is also 2 by 5. So what we can conclude about this whole discussion is that the gradients are equal, their gradients are equal, or the gradients of opposite sides are equal. The gradients are same or equal, are same or equal of the opposite sides. It's really important that you have to give the conclusion in your exam as well. So try to learn and practice these questions well before exam. I hope you are clear about today's lesson. For next difficulty level, please catch me in the next class. Watch my lessons, like, share and subscribe the channel, and press bell icon to get the notification of every lesson in time. Thank you very much.